and as they come, and otherwise we'll do this. Yes, and this class talk, whatever it is, workshop, whatever it is that we're calling it, is on SSRF, which is server-side request forgery. The fun subtitle that I got for this is "Why Make a Request When Someone Else Will Do It For You?" Who am I? I'm Jeremy Mill. I am an application security engineer. In my day-to-day job, I am like 80% blue team, like 20% red team, which means that like when our team releases new features, I get to go do some pen testing and find bugs, right? But I usually do a lot of that as like white box testing, which is like, as opposed to like, you know, somebody doing a bug bounty, I've got source code, and so I get to cheat, and it's great, and I love it. How I got here is its own interesting story. But I was SIGINT in the Marine Corps. Then I became a developer / consultant. I was also a sysadmin in there somewhere too. Then I worked at Otis Elevator as a developer. Then I moved full-time to security. Then I worked at Simple, you know, RIP, they got shut down, also in security. And now I'm at Flowcast. So I've kind of found a little bit of a niche in the fintech world, which is cool because it's really fast paced. And I love the fact that the bad guys are real, right? They're present and they're attacking you in a very realistic way all the time. I apologize profusely to everybody on here. I don't have a top hat. If you don't know why I'm apologizing for not having a top hat, you should hang out in the OC Slack more often. So SSRF, what is it, right? If we know nothing. So the definition for this is we're going to abuse the functionality on the server to read or update internal resources. That's kind of like bland and dry, and I ripped it out of the OWASP page on SSRF, which is actually very good. You should read it. But the easy definition is we're going to get a server to make a request for us, right, on our behalf. Right, so Eve, our attacker, right, is like, hey, server, go get foo from bar.com for me. The server goes, sure. It makes that response on our behalf as itself. You know, as opposed to maybe something like a proxy server, which is going to be very careful to let bar.com know that, you know, that request is coming from us using like the X forwarded for header and all sorts of things like that. That's all well and good, but why do I care, right? Well, the primary way that this is abused, right, is to make requests to internal or other restricted resources, or to change the context in which those requests are made, right? You know, it's very often in architecture, right, especially in enterprise architecture, to have, you know, particularly in like microservice land, so that if I make a request to you know, internal.bar.com as my user with my authentication token, bar.com is going to go, you get nothing, right? Give me back a 401 or a 500 or something like that, right? Give me absolutely nothing. But if public.bar.com makes a request as itself, right, not as me, the end user, right, it gets back a very different context, right? It gets back useful information or more information or sensitive information. And we want to try and get the results of that back. It's worth noting here that any URI or path is a potential SSRF payload, right? So it's very easy when we're talking about web applications to just kind of think inside the box here, which is we've got, you know, HTTP, we've got HTTPS, but we can also, with SSRF, make like gopher calls and calls to the file system. And we can make calls to different ports on services. And sometimes we'll get back interesting responses, especially if we're, you know, if we're calling curl underneath the hood or something like that. So yeah, any URI can be a valid payload. It can also allow an attacker to hide their identity by abusing your resources, right? It would be great if I just find a site that has SSRF that will let me launch attacks on some other site and hide my identity and hide that I'm North Korea or something. And then kind of we alluded to this before, but it's also a really great recon tool to port scan internal resources and gain insight for launching other attacks. So what does this look like in a picture? Right, we've got our attacker here, and he's like, hey, I'd like the resource / private. We've got an ALB here that's maybe doing OAuth or something in front of us, because these are all AWS icons. The ALB is just going to return a 401. It's like, get stuffed. You don't earn that. But this public server over here has an SSRF vulnerability. It's saying, hey, give me /SSRF and our URL of private. Well, public server then makes a request to that internal service on our behalf, sends the response, and the public server forwards it right along to us. And we've bypassed the controls that our ALB was supposed to be providing for us. We've bypassed this trust boundary, right? If you're at all familiar with threat modeling. Do you have any questions so far from anybody on what SSRF is, or why it is that you should care about it before we start jumping into the next thing? We're going to do some practical examples of looking at it.
Hey, Jeremy, there's a couple questions in this chat.
Yeah, let me open the chat.
And I know you probably can't see because you're sharing your screen, but I don't know if you want me to read it out as you go, or do you want to wait until the end when you do the Q&A?
Just popped it open, so we'll try and answer some of these here. We'll have a couple of breakpoints. Is this a client server version of the confused deputy? I am not 100% sure of what the confused deputy is, so the answer is maybe. If you want to try and clarify that question, I'd be happy to answer it. Or we can do it at the end. I don't want to put you on the spot.
Sure, if you can hear me all right.
Yep, yeah, totally.
So yeah, the confused deputy is a like operating system kernel type attack where processes that shouldn't have kernel privileges basically they gain access to other processes using this type of thing.
Oh, cool. Yeah. So maybe, right? It's probably more like the lines between a lot of these attacks get really fuzzy, right? And we call them different things when they're like kernel attacks and we're doing memory or processor stuff versus when we're doing web attacks, right? But like the line between a directory transversal and a SSRF can get fuzzy, and it's really just about like the context in which, right, are we forwarding a request, or are we just getting to a different resource, right? Like, can something look like a path transversal that's actually an SSRF? Like, yeah, it can, right? So the answer is, I'm not 100% familiar, so I don't want to say yes, but probably. They're probably really similar, or at least have similarities. All right. So enough slides for the moment, right? We got a couple more, but let's look at what SSRF looks like. So you all can get to this as well, right? And this is at target. Well, don't edit the slide, Jeremy. Target.livinginsin.com, and this one is running on port 8080. And I'm going to show you some quick stuff, and then I'm going to ask y'all to take a couple of minutes and try and get a flag from this server. If you're not familiar with like security competitions, like capture the flag, a flag is just some secret piece of information that you should try and get. And the two flags, I'll accept either one of them, not that there's any prizes, unfortunately, are get a sensitive local file system file, or get the private IPv4 DNS name. And I'll give you a hint, this is running on AWS from this first SSRF challenge. But before we do that, right, like a quick introduction to what it is that we're doing before you all hit it up, right? This is some fancy web service. It's a super popular app, as it says. And they have a new webhook feature, and it lets you put in a URL in order to test that your webhook is working correctly. So one of my favorite payloads, right, is a really easy one, because we can just do something like and this is api.ipify.org. And what we can see in this one, actually, if we open it up in our browser, right, is it's really nice to us. It just returns us what our current IP address is, right? So if we're writing scripts or whatever, it's a nice little easy API that we can use. What it is that we can see here is you can tell, sorry, I shouldn't have just closed it. When I ran it, right, from my browser, I get my IP address, right? I get 70.172. And when I run it on our SSRF page, we'll notice that I get back the IP address of target.livingandsin.com, right? This lets me know that I have an SSRF, right? And not like something happening in the DOM and JavaScript making this request out for me, right? Which would be a handy way to do this page actually, right? So that we're not expressing ourselves up into an SSRF. But in this case, right, we can tell with certainty we have some level of SSRF here. We don't know that we can do anything dangerous with it yet, but we've got SSRF. We're making requests in the context of target.livingandsin.com out to this API. Now, this is really handy, right? And this is super easy because this is just telling us, it's like, hey, here's your result, right? And it's spitting things out for us. We tried to make it nice and dummy proof. But what if we didn't have this result, right? What if we couldn't necessarily see the output, right? There's lots of black boxes in web applications where we put in data, and sometimes we, maybe we're putting in intentionally bad data because we're black or gray hat or white hat hackers, right? But we think that there might be an SSRF in there. Well, that would be like a blind SSRF, right? We can't see the output directly. In that case, if we wanted to test it, what we could do is we could use a domain that's under our control. And what I've got here is
Jeremy, can you just zoom real quick so that people can see better?
Zoom in on both of these so that they are much bigger. All right. Sorry, is that a little bit better?
Maybe a bit bigger.
All right,
those of us
a little bigger.
that need glasses.
Sorry, should have dropped down the resolution on my screen a little bit. Apologize. How's that?
Cool.
And so what we can do with this is we can use a domain that's under our control, right? So livingandsin.com, right, without the target subdomain, is a domain that we control, right? We have that server somewhere else. We can use something like netcat to open up a listener on it, right? And we can test it. What we'll see here is we actually get a bunch of really fun metadata and the connecting IP address of the server that we're targeting, right? So let's say that this is actually a request that's being passed off to another service and to another service, and that was the thing that was actually vulnerable to server-side request forgery. This would let us know the IP address of the actual target that is vulnerable, and we'd get out some really fun information out of it, right? So we can do something like, just do foobar and close it, and we'll also sometimes get a result out of that. But the point is that there are ways to detect SSRF, even if we are unable to directly see the output from it. So yeah, at this point, what I'd like y'all to do is go to that site, right? target.livingandsin.com, word 8080, and try and get a sensitive local file system file or a private IPv4 DNS name for that target. And you can feel free to put what your payload was into the chat or let me know, and we will go over some of the solutions here very shortly as well. How's everybody doing? Anybody got any questions? You can feel free to just unmute and ask them or throw them in the chat or whatever works.
So I've never done one of these before.
Mhm.
What are some approaches that's easily explainable in 1 minute?
Sure. So a hint that I will give you is a couple minutes ago, one of the things we said was that any URI or path is a potential SSRF payload. So URIs are really commonly, right, HTTP, HTTPS, but they are also file. They are also SFTP : / They are also really just about any resource can be expressed as a URI.
Yeah, so the first thing that I'm doing that I'm getting kind of interesting results, not the flag, but a thread that I'm going to start pulling on HTTP : / localhost.
That's an awesome idea. Right, and we'll see that what we're getting, right, is the same target that we're on, right?
Right.
And that's an awesome target for an SSRF. There's a lot of APIs that are available to localhost that aren't necessarily available to the public, right? So they might have restriction of like, oh, the IP address is 127.0.0.1 or something like that. Another thing would be, I let you all know that this is running on AWS, right? And a good thing to try if you have SSRF is try and find out where we're running, right? Now we might already know because we did a IP info lookup or something like that during our recon phase, but let's say we don't. And we got one good one, right? User bin, who am I? Right? If we do that, we don't get anything. But what are we missing at that? That's a really good point, right? Is any path is a potential one. But what do we need to do to turn that into a URI? Ah, cool. That's really interesting in output, isn't it? Right? We happen to know this is just right. That ELF gives us a good insight if we've ever touched some reverse engineering that we're looking at a Linux executable. But what about a text file? How about Etsy password? Right now we have a list. SSRF has given us a list of all of the active users on this system. Right, and now we can go and we can like brute force SSH logins or whatever else. I mean, don't do that because it's a key-based login, and I'm not going to let you all SSH into my box before I shut it down. But hypothetically, this map would be right, or we can start leveraging that against other things. Maybe this page has a login page somewhere, and they're using PAM and they're going against localhost. The other one would be right if we did go and grab our instance metadata, right? We can get our local IPv4. Right now, we can start doing recon against what the internal network of my VPC looks like. Right, is running on a 172.31.36 network. It's not going to help you a lot because this only has 2 hosts in it. But if it wasn't, right, we now have a ton of insight that really we should never let attackers be doing getting that. AWS, Azure, and GCP have done a bunch to limit the scope of what can happen using these metadata IPs. But if they're on older AMIs or they are instances that have been up for a long time, they're probably still vulnerable and using the older version of this. And you can sometimes get out like S3 credentials and then go and dump entire S3 buckets or put malicious files into S3 buckets. And you could really just in general be a really malicious, terrible person. Sometimes you can also dump like environmental variables and you can get out like API keys or database passwords or all sorts of fun, really, really dangerous stuff. Anybody have any questions on this challenge before we move on to, a couple more slides and then we do, we'll do another challenge similar to this?
Hey, Jeremy, is the vulnerability here that the input to the form is not sanitized before being executed or parsed, or where's the actual vulnerability?
Yeah, so that's a really good question. Yes, it's that it's not being sanitized. But what we're going to get into is that making requests that are based on user input is really hard and needs to be done with like there's like sanitizing text or like sanitizing something for command line injection, and they're sanitizing really well for SSRF, and it turns out it's really hard, which is kind of what makes this a classically recurring problem. So yes, it is sanitization, but it's a particularly hard sanitization problem to solve.
Okay, yeah, cool, thanks.
Cool. All right, we're gonna hop back over to, here's where we were. And all right, yeah, so we alluded before, right, that we can map the internal network. And what does that mean, right? So once we have an SSRF, we probably want to start making requests against the internal IP ranges, right? And we can script this, right? We can make requests. A hint that I'll give you all right now, I did not do anything very high up in an IP range for any of these testing things, right? So if you make it to like 10.0.0.8, you have gone too far. And then the other thing you can do is you can also start trying out, let's say they've done a lot of filtering around IP addresses. We touched briefly on the fact that there's this internal AWS, GCP, Azure host name schemes, which are rarely, if ever, changed from default. And you get things like IP address .aws region.compute.internal, right? And things like that. And those are really valid targets as well. So we had the question a minute ago, which is this a sanitization problem? And yes, and it is, but there's lots of, it's really hard to sanitize for this. If we're going to go down this path of making requests to resources based on the user's input, right? So one is, right, filters. Let's say we have a filter that does a really good job of testing for IP addresses, right? Well, we can use domain names that resolve to internal IP addresses. If you do an NS lookup on 101.livingandsin.com, it resolves to the internal IP address 10.0.0.1. There's also all kinds of alternate IP address encodings, and it's a nightmare for sanitization. So the IP 10.0.0.1 is exactly equivalent to 10.0.1. which is also equal to 10.1. 10.1 is a valid IP address format, which is also equal to the decimal representation of this. The localhost loopback IP address is also the entire 127.0.0/8 network. So everything in the 127 IP address space is your loopback address. So you can't rely on loopback only being 127.0.0.1 because it's not. Also, whoever made that decision has made a lot of people very, very angry. Also IPv6, which, you know, a lot of people, especially if we're talking legacy apps, people just kind of forgot existed, but the operating system underneath it and all of the libraries that it might be calling, whether it's curl or requests or whatever, right, understands it perfectly well. And you can do all kinds of things, including things like tunneling IPv4 addresses in IPv6 addresses, because that's a supported feature. There's also all the usual string parsing bypasses, right? Putting spaces and things where they don't expect them, null bytes, double URL encoding, all kinds of tricks. OWASP has like a 20-page list of string filter bypasses that is worth looking into, including like hex encoding, UTF-7 encoding, which is like not a real thing, but computers do it because we ask them to. And then there's DNS rebinding. And this one is I think one of my favorites. I say favorites loosely. Let's say that an attacker owns the domain evil.com, right? They set up a subdomain foo.evil.com. And when you resolve to it the first time, right, when you do an NSLOOKUP to foo.evil.com, it resolves to an external IP address, right? A perfectly valid one. And it has a very short time to live, or a time to live of 0. And there's a lot of services which might try to do something like, oh, I'll resolve a domain to make sure that it's not an internal resource, right? But then I'll cache it so that I don't have to do this lookup every time, right? In something like Redis or just in memory, right? So that, you know, I don't slow the user down. The problem is that when you actually go to make that request again, if the TTL is expired for the DNS cache, you'll make another DNS request, right? In which case, now all of these subsequent requests will resolve foo.evil.com to an internal IP address, right? And this is a form of a cache incoherency bug, which can lead to an SSRF filter bypass. There's also usernames or passwords in URLs, right? So like http://username:/password@example.com, right? So this is really useful when an SSRF lets us append to a known good domain, right? So like they're like, oh, we'll always say that the domain is example.com, right? It's always going to be example.com, and we'll just add a path to it, right? That way we control the domain, right? And everything that's on example.com is fine. But if our SSRF payload is @evil.com, then we have the username example.com being sent as a request to our domain evil.com. And then there's a really cool one that I encourage you, right? This is one of those exercises left to the reader type things, which is TLS ticket reminding. Which is TLS does its own form of session resumption, and you can use that to leverage and get SSRF as well. I linked a GitHub here, and I will share these slides out after so you can go and take a look, but it's really fascinating. This was at Black Hat, and it was a wonderful, awesome, cool talk. That's on the more advanced side of things, but it's super cool. So some more hacking, right? We've got another internal service, and there's 2 levels to this. The first would just be try to find the IP of another internal service that's running, right? And then if you can, get the flag from that service. And the service here, it's going to look the exact same, but it's going to be slightly different. We're at target.livinginsin.com, port 8081. So it's 8081 for this one. And I'm going to bring some of our bypasses back up, and I'm going to leave those on the screen for the moment. And I'm going to let you all do a little bit of hacking, try and do some bypasses. And I'll keep My chat closed for some reason. We'll open that back up. And let me know what you find. Let me know your questions. And let's see what it is that you can find. Y'all can also feel free to collaborate because hacking is absolutely a team sport. Believe that with every fiber of my being.
Feel free to talk out your process.
Yeah, so I saw, you know, that the injections had to be HTTP, or that's kind of how the filter was oriented. And so I started walking up some IP addresses and found the 10.3 returns a restricted area. So we have some kind of host or restricted resource there that I think is probably what we're trying to access.
Nice.
Currently where I am. And then when you throw like a login at that, you get some interesting stuff.
I will admit I have absolutely no idea what happens when you throw a login at that one. So if it does something even more cool, yes, cool, you found the flag. Good work. How's everybody else doing? Anybody else got any different ways of doing it besides the username? All right, we'll give people another 1 or 2 minutes, then we'll go over a couple answers. We got one more little bit different challenge after this, right? Try and make you keep you on your toes a little bit. So Joe, this is the method that you went with, right?
Yep.
Cool. Was anybody else able to get the flag? So we could have also just gone with 10.3, and we would have been able to get it. We could have also gone with .103.livingandsin.com, because I have at least a few of these that I change regularly on my DNS, because, you know, gotta keep things interesting. Let's see, I'm not sure if any of these other ones would have worked for us. DNS for binding would work, but not on the first request, right? This isn't something vulnerable to that. IPv6. I don't remember. Let's try it. I'll have to find where that is again. Fairly sure that I owe y'all a cool proof of concept for that. It is this. Let's just try it while we're here, and then we'll. I owe you a cool proof of concept for that one. I will put it into the OC Slack at some point, but that one should also work. Null bytes, by the way, are a particularly fun one. It's not going to help you in this one because just won't. But it is a really fun way to end a string earlier than it wants to. And they're particularly useful for APIs that want to make sure that like the file you're requesting ends in .pdf. Well, if you add a null byte somewhere in the middle of the string still ends in .pdf, but if you send it to a shell or to a foreign function interface or to another ABI or something like that, it might stop parsing the string right at the null byte, and you can get all sorts of fun information out of there. This is particularly useful with anything that's like C++ based or PHP. Node is also vulnerable to poison null bytes. They're a really fun one. All right, we got one last one, and this one is a little bit different. This one doesn't have a very nice, pretty GUI behind it. But our last target is at target.livingandsin.com, port 8082. And it's this /icon API, right? So if we take this, right, and we take a look at what happens here, if we go to, you know, we make a request to /icon/1, right? We get user ID 1 and we have an icon path here, which isn't particularly interesting by itself. What we do also have is a put request to this REST API. And the payload has to be an argument named icon path, which is a relative path to, I apologize, this should actually say to livingandsin.com and points at an image, right? So if we look at livingandsin.com /icons-png, right? We have a whole bunch of PNG files here. And if we do a put request to target.livingandsin.com /icon, and we'll change this user ID. It's /icon at the end of it. There's no GUI for this one. So that's what, yeah. So /icon/1, right? If I change this to, sorry, you actually have to copy it if you want to paste it. Right, we'll change this to a different user ID and try to use a different user ID than 1 or 2, right? Pick some random string of digits for your testing, right? What you get back is user ID 2, and then you get back a giant base 64 encoded image. So again, right, we've got the put is going to target.livingandsin.com port 8082/icon and a user ID. We're passing it an icon path, and it has a path relative to livingandsin.com. And that should be right in that livingandsin.com/icons-png. And I will try and update this document real quick while y'all are
Hey,
on
Jeremy,
this.
can you address this last chat for 8082? I'm not getting in. I think Joe can't either.
Yes, it should be /icon/1 should give
Okay.
you. So right at just the index at the root, there's nothing there. There's an API, a REST API at /icon. And so these should be the 2 curl commands that should help you exploit what's going on here. Not those ones. Hold on, let me bring them back up.
Hey, so sometimes I get user ID 1, other times user ID 2. What's the significance of that again?
Yeah, sorry. Each of you should be picking, you should pick some random value for after /icon, right? The user ID is just in that URI. So in that URL. So pick some random number besides 1 or 2 for yourself. You know, pick 742 or something, and that's what you should use for your testing. That way, you're not clobbering someone else. The /1 is just a user ID. It's really any string. Right, so if I do a curl to icon/foobar, right? Clear my screen, right? That'll work just as well. And then if I do a get to /foobar, that'll work as well. So this is just any user ID that you're choosing for yourself. And again, please share and feel free to say what it is that you're doing. Say if you get any interesting behaviors, anything that you're able to get out of here.
Sorry, maybe I missed something, but like, what's the goal of this one again?
Yeah, the goal is very similar to the last one. Sorry, yeah, that's that's a totally fair question. There's a flag running on another service on this internal network, and our goal is to get the flag off of that service. Very similar to the last one, but with a less GUI approach.
So just to be clear, Jeremy, the base 64 or whatever, is that like the image of the icon itself? Okay.
Yep.
So
this is from livinginsyn.com/icons/add.png.
Right.
Right. That's add.png base 64 encoded.
Right. And so the flag is going to be essentially very, very small. Right.
That would be a good sign that you're on the right path. You get a small base 64 answer, you're in a good spot.
So I'm thinking about like directory traversal and trying to put weird stuff into icon path. It is accepting a period, which shouldn't be a valid path, and I'm getting some kind of image back from that. But I can't seem to kind of like traverse back up the directory.
So let's think about this, right? We know that we are attacking target.livinginsyn.com. And we know that our API documentation tells us that, right, icon path is relative to livinginsyn.com. Right?
Yep.
And we're getting back a response that has a value from livinginsyn.com. So we know that at some point, target is making a request to livinginsyn.com.
Yep, tracking up to there.
We want to make a request. We want to make target make a request to something else.
So I did get by putting in like icon-png/... I don't know if I'm trying to like go back up the path somehow, but the response was a lot smaller than before.
Yeah, I'll be honest, there could be a directory transversal in this, right? But that would be a different vulnerability than an SSRF. So if we're just doing this, for example, right? Yeah, we get a really boring internal error, right? We're getting this out of it, right? By doing a directory transversal. We can always you have any idea how many times in my life I've typed in base 74 and gotten an error, and I have no idea why I've not built an alias for this yet.
Make it a thing, yeah.
Right? We get some invalid input, but we're getting, right, the target, right? We're getting some weird stuff out of this, right? And that's cool, right? It does seem like there might be a directory transversal in this. But I will tell you that that is not what it is that we are, that's going to be our SSRF vulnerability to get the flag.
For the SSRF stuff, should we be thinking about the /icon/user ID, like that?
Right. So
Because that's the URI.
when we're doing, sorry, let me do a valid one again, right? When we're passing an icon path, we know that we're making a request that is, open up this code here, make it real big. And we know that we've got, you know, That's the path that we just passed in, right? To icon path. So we know that at some point we probably have some code that looks like host plus icon path, right? You know, maybe it's something like HTTPS plus host plus icon path. So we need some kind of bypass that lets us bypass this statically defined value.
You gonna pull up your slide with the bag of tricks again?
Absolutely can. That is not the right one. Yes, it is. Yes.
By passing in \0, I got the browser or proxy sent a request that this server could not understand.
Hey, that's cool. That's progress. You're kind of weird stuff. Weird stuff is always progress. So let's try. Got an interesting pause that time though, didn't we? Pauses and things that take time to process are always interesting. But in this case, right, if we went back, we open up VS Code again here, right? And let's imagine that what is URL going to look like if we pass in this as our payload? Exactly. Where does that request go?
To .3.
Mhm.
Okay, so there was a .3 that, yeah, is potentially alive and didn't know how to parse that request, maybe.
So I'm using Insomnia to like, just for like a GUI for all of this.
Mhm.
And yeah, just putting icon path like at 192.168.0.1 or something is like 30 seconds, 40 seconds.
You might need, depending on what you're using, right? You might need to URL encode your payload. And I'm actually not sure what the behavior is in mine. It would be something that I would try.
Jeremy, can you
get
talk to me
interesting
more,
pauses out of it.
more about your timing comment on the .3? So like I'm
Yes.
on the .4, but I'm getting weird time out of everything up from .3, 0.5 through 7.
So what did you get out of .4?
I mean, I could post it. A short flaggish looking.
What did we say that value was going to be? Yeah, that decodes to the flag.
Just a time check-in, Jeremy. We're a little after 9.
Yeah, we should be ready to do some final questions and wrap it up here. So my question about timeouts was not necessarily that there's anything particularly interesting about .3, but about the fact of what's happening in the underlying system, right? When we hit something very, very, very quickly in code, right, we probably hit something in code, right? Versus we can get timeouts when we reach out to external systems. And it's really useful for us to detect cases where we have, maybe blind injection or blind requests or things like that, right? So that's why attackers a lot of times for like testing SQL injection will use the sleep command, because it's a really useful way to say like, oh, okay, I ran this command with a sleep in it and I got a definitive 3-second pause. Every time I do this, I probably know that I have some form of SQL injection, even though I can't get an actual value out from the system. And so that'll give you, right, timing is a really useful way to gain insight into what's happening in a system and know whether you're making calls to external resources or whether or not you're actually getting some kind of like suitable injection. It's not foolproof, but it's a sign usually that you're on the right path.
Okay,
So you're getting weird behavior.
We're operating on the order of network latency, not internal code latency. Yeah, I gotcha.
Exactly. Yep. So yeah, that was. Oh, go ahead, please.
So basically, keep throwing stuff at it and see what changes the output.
Kinda, right? And so this starts getting into the category of buzzing. And so when I'm doing testing like this, and tools like Burp have tools built in to do this, right? You can throw an entire 172 network space at potential SSRF vulnerability in a very short period of time and look at all of your requests that come back, right? And have a really good idea whether or not you can find some internal space rather than, right? Very rarely are you going to be really sitting here doing this by hand, right? If you're doing this at scale. And so going through an entire 10 dot address space or 172.16 or 192.168, right? You'd automate that, and it would be a script that you'd send out against the entire thing, and you'd go and look at how long did it take for my request to come back? Did I get anything that wasn't, maybe I get all 404s except for a couple of 401s and a couple of 500s, right? Something that'll help you narrow it down and start digging into the find your weird behaviors and start. Was it just weird because like it really didn't like the input I gave it, or is it weird because it's doing something weird and that it shouldn't be doing?
Another question: if your script happens to basically go the whole range without, I don't know, the server cutting off that connection or preventing your IP address from continuing, is that a sign like they're not using something like fail to ban or things like that? So they probably don't have a fully hardened system if you're able to ping that much.
Yeah, and right. I mean, I'm an AppSec guy, right? So I frequently am able to test from the perspective of like, there's never a WAF in between me and the application that I'm testing, right? And I can like test against debug environments, and I can be like, can you turn off rate limiting for me, right? That'd be great. But if you're actually doing like bug bounty type stuff, right? There's some really common burst limiting rules, right? And ones that are like 500 requests in 5 minutes, right? Is AWS WAF's lowest setting for rate limiting, right? And so like you can just rate limit yourself to stay just underneath it and go from like, oh, this will be done in 30 seconds to like, I gotta let it run for an hour, you know, or 4 hours, right? Let it run overnight, and get to it. So yeah, you should be able to put some compensating controls in place, but they're going to be they're going to be compensating controls. You'd still be able to find and exploit the bug if you're an attacker really looking at a system.
Any other questions?
All right, well, thanks everyone. I'll be around if you have more questions. I'm gonna leave these targets up for probably a couple more days. So if you want to go poke at it, you're more than welcome to. I'll leave them up for a little while. If you have questions, please feel free to ping me. I'm happy to answer them. If you want some harder examples, the Port Swigger Web Academy has some really good ones, or I also have some harder ones from a different class. I'd be happy to share out or put up on my GitHub or something. Yeah, so thank you so much for coming. It was awesome. It was a lot of fun teaching this, and thank you.